Okay, so the next question is supposed to be, of course, question number 4, but for whatever reason I didn't really understand the solution. I mean, the solution is kind of I didn't really understand it, so I can't really talk about it. Question number 5 is basically 5 squared plus 6 squared plus 7 squared plus all the way up to 20 squared, right? So you can essentially write this as, if here n is equal to 1, you have basically n plus 4. If here n is equal to 1, then here you have 1 plus 4, so you have n plus 4 whole raised to the second power. If over here again n is equal to 2, then this is equal to basically 2 plus 4, so n plus 4 raised to the second power is equal to n plus 4. So if n is equal to 2, 2 plus 4 is equal to 6 squared. If here n is equal to 3, then you have n plus 4, which is equal to 7 raised to the second power, and so on and so forth. Which means that here a of n is equal to n plus 4 raised to the second power. And so what that means is that a of n is equal to n plus 4 whole squared, which is the same thing as n squared plus 8n plus 16. A of n is equal to this, and therefore you can write basically S of n is equal to sigma a of k as basically as k goes from 1 to 20, right? As k goes from 1 to 20, because you have 20 terms here. Actually not 20, but it's not actually 20. So your terms start from basically, so you have 5, 6, 7 all the way up to 20. That means that you have well, if your terms started with so from a 5 to 10, so you have 5, let me see. So let's do an experiment. So for example, what is the number of numbers from 17 to for example 25, right? So you have 17, 18, 19, 20, 21, 22, 23, 24, and 25, including both of the numbers 17 and 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 9 numbers. Which means that if I write 25 minus 17, that's going to give me 8. And so I have to add, of course, a 1 to this number to get to the number of numbers. Which means that 20 minus 5 is equal to 15. That's 16 terms. So k goes from 1 to 16, right? K goes from 1 to 16. Of course, here I could actually find the sum of n terms of this series, and then put n is equal to 16, for example. That I could do as well, meaning that I could write k goes from 1 to n, and then calculate basically the sum of the series based on, because this is a finite series, of course. So I could write this as basically sigma n squared plus 8n plus 16 as k goes from, of course I have to write this in terms of k. So I can write it as k squared plus 8 times k plus 16 as k goes from 1 to n, for example. That of course we could do. And therefore we could write this as sigma of k squared as k goes from 1 to n plus sigma of, because actually we don't have a formula for that sort of thing, meaning that, for example, to go from 1 to 20, the formula would not be easy to use. So, and I write this as 8 times sigma of basically sigma of k as k goes from 1 to n plus sigma of 16 as k goes from 1 to n, right? So so this would be basically sigma of k squared as k goes from 1 to n is basically n times n plus 1 times 2n plus 1 divided by 6. Sigma of k as k goes from 1 to n is equal to n times n plus 1 divided by 2, and there is an 8 over there to be, so 8 divided by 4 is equal to, divided by 2 is equal to 4. And then over here you have basically sigma of 16 as k goes from 1 to n, which is equal to 16n, right? So that's the same thing as basically, just calculate these one by one. So n squared plus n squared plus n times 2n plus 1. That is the same thing as 2 times n cubed plus n squared plus 2 times n squared plus n. So that's this first part over here, 2 times n cubed plus n squared plus 3 times n squared plus n divided by 6. And this is the same thing as basically n squared plus n squared plus n times 4 would be 4n squared plus 4n. 4n squared plus 4n. And of course, that's not a part of this. That's not a part of this thing over here. So that's basically n squared plus n. So that's plus 4 times n squared plus 4 times n plus 16 times n, which is the same thing as basically, 2 times n cubed plus 3 times n squared plus n, and divide that by 6 plus 4 times n squared plus 20 times n. And then divide here, basically take LCM as 6, 2 times n cubed plus 3 times n squared plus n plus 24 times n squared plus 120 times n, and 2 times n cubed, 3 plus 24 is equal to 27 times n squared plus 121 times n divided by 6. And then you can 121, you can divide it by 11. I think that's the only number that you can divide it by. This is divisible by 3. This is, so you cannot simplify this any further. I suppose then S of n is equal to then 2 times n cubed plus 27 times n squared plus 121 times n, and divide that by 6. Right? Now if I calculate if I put n is equal to 16, if I put n is equal to 16, let's see if that actually works. Now S of 16 is equal to 2 times 16 raised to the third power plus 27 times 16 to the second power plus 121 times 16 divided by 6. Well, this is not easy to calculate. I think we should have left all of these. We could actually go back over here and use this formula, meaning that we could essentially use this formula over here, meaning that we could say that S of n is equal to n times n plus 1 times 2n plus 1 divided by 6 plus 4 times n times n plus 1 plus 16 times n plus 16 times n, and then use this formula. So we could essentially forget about all of these. Because that makes things a little bit more, meaning that things get harder that way. So now S of 16 would be equal to 16 times 17. 2 times 16 is equal to 32, so 33 divided by 6 plus 4 times 16 times 17 plus 16 times 16. Well, now you need to find somebody to calculate this for you. Okay, so let's do that. So divide by 2, you will get an 8 here. Divide by 2, you'll get a 3 here. And you'll get an 11 here. Right? So that's 88 times 17. 88 times 17, which is basically 56, 5. 7 into 8 is equal to 56. 56 plus 5 is equal to 61, 0, and then you have 88 there, so you have 6, 9, 14, 1496, that's 1496. Now 4 times 16 is equal to 40 and 24, so that's 64 times 17, which is the same thing as 28.2. 47 times 6 is equal to 42, 44. 42 plus 2 is equal to 44. 0, 64. You have an 8 over there, you have an 8 over there, you have a 10 over there. So that's 1088. 1088. 16 squared is equal to, that's one of the things I said we should do. I never actually did it. I mean, the square of these numbers. So 6 times 6 is equal to 36, 690, and you have 16, so that's 6, 15, 256, 256, and then you can calculate all of these here as 1496 plus 1088 plus 256. So that's a 14 plus 6 is equal to 22. So that's 17, 19, 19 plus 5 is equal to 24, 2. That's a 4 plus 4 is equal to 8. And that's a 2840. 2840. Which is correct. Okay. Well, these kinds of things are actually useful in many types of situations. For example, if you know how to calculate this sort of thing, of course you could do many different types of things with this, meaning that I mean, how else would you really add these numbers together? That's actually a very good skill to have, right? Okay. So so 200. So the next question is question number 6, which is 3 times 8. The series is basically 3 times 8 plus 6 times 11. 6 times 11 plus 9 times 14 plus so on and so forth. So here you have times 3 times let me see if I can find the number. Okay, so now as you can see, if here I take n is equal to 1, then this is basically 3 times n. If I take here basically n is equal to 2, this is 3 times n. The n is equal to 3, this is 3 times n. So the first number can be written as 3n. And the second number can be written as, you see that the difference between these two numbers is 5. Again, the difference between the two numbers is 5. Again, the difference between the two numbers is 5. So that's exactly 3n plus 5. And that is your a of n, right? So that's equal to 9 times n squared plus 15 times n. Which means that your S of n is equal to sigma a of k as k goes from 1 to n. As k goes from 1 to n, which is equal to sigma of 9 times k squared plus 15 times k as k goes from 1 to n, which is the same thing as basically 9 times sigma of k squared as k goes from 1 to n plus 15 times sigma of k as k goes from 1 to n. That is the same thing as, you know, that sigma of k squared as k goes from 1 to n is equal to n times n plus 1 times 2n plus 1 divided by 6, and sigma of k as k goes from 1 to n is equal to n times n plus 1 divided by 2, right? Divided by 2. So having these in mind, so I can write basically I can write basically 9 times sigma of k squared, as k goes from 1 to n, is equal to 9 times n times n plus 1 times 2n plus 1 divided by 6, and divide by 3, you'll get a 3, divide by 3, you'll get a 2, plus 15 times n times n plus 1 divided by 2, right? 15 times n plus 1 divided by 2, and so here basically you will have 3 times n, so the LCM is automatically 2, so 3 times n plus 1 times 2n plus 1 plus 15 times n plus 1. Now that is the same thing as basically, that's the same thing as, so keeping this 3 outside, n squared plus n times 2n plus 1 would be equal to n squared times 2 times n cubed plus n squared plus 2 times n squared plus n, which is equal to 2 times n cubed plus 3 times n squared plus n, and multiply the 3 by all of them, you will get, you can essentially take 3 out. We can essentially take a 3 out here and write this as 3 times basically n times n plus 1 times 2n plus 1, 2n plus 1 times 2n plus 1 plus 5 times n times n plus 1 times n plus 1 divided by 2, which means that then basically this first part becomes that's the same thing as basically, let's write it this way. Let's write it as basically 3 halves times basically this part is basically 2 times n cubed plus 3 times n squared plus n, and then and then over here you have n squared plus n squared plus n times 5 would be 5 times n squared plus 5n plus 5 times n squared plus 5 times n, and so you have basically 3 halves times 2 times n cubed plus 8 times n squared plus 6 times n, and from here you can take a 2 out and you can write it as 3 times 2 divided by 2 times n cubed plus 4 times n squared plus basically take a 2 out, 3 times n, and then you can cancel out 2 and 2. From here you can take an n out, 3 times n times n squared plus 4 times n plus 3, and if you basically, you can write n squared plus 4n plus 3 as basically n squared plus 3n plus n plus 3, and there you will get, n times n plus 3 plus n plus 3, and that would be n plus 1 times n plus 3. So that's the same thing as 3n times n plus 1 times n plus 3, and that is your S of n. That is, therefore, your S of n is equal to 3n times n plus 1 times n plus 3. That is basically the sum. Okay, so the next question is supposed to be question number 7. But I didn't really understand this question. I mean, the question is a little bit unusual. There is no way to, I did try, but couldn't find any rules for this series. It's a little bit, it's a little bit, I just don't understand it. So let's skip this question, because I have to really, I cannot really talk about this question. So the next question that we have, basically we have 3 more questions left here, and in these 3 more questions you want to find the sum to n terms of these series whose nth term is given by, so for example, number 8, your a of n is equal to n times n plus 1 times n plus 4 times n plus 4. And so over here, if you multiply, you will get a of n is equal to n squared plus n times n plus 4. And that is the same thing as n cubed plus 4 times n squared plus n squared plus 4 times n, which is the same thing as n cubed plus 5 times n squared plus 4 times n. And then that would be your a of n. That would be your a of n. Moreover, if you want to find S of n here, you can write sigma a of n as actually you can write sigma a of k, for example. Sigma a of k as k goes from 1 to n, which is the same thing as sigma of n cubed plus, or you can write that as k cubed. You can write that as k cubed plus 5 times k squared plus 4 times k, as k goes from 1 to n, which is the same thing as sigma of k cubed as k goes from 1 to n, plus 5 times sigma of k squared as k goes from 1 to n, and plus 4 times sigma of k as k goes from 1 to n. Now what that is that basically you know that sigma of k cubed as k goes from 1 to n is equal to n times n plus 1 times 2n plus 1 divided by, it's equal to n times n plus 1 whole squared, which is n squared times n plus 1 squared, divided by 4. And you also know that sigma of k squared as k goes from 1 to n is equal to basically n times n plus 1 times 2n plus 1 divided by 6. And you also know that sigma of k as k goes from 1 to n is equal to n times n plus 1 divided by 2. Put these together in this form, you will get sigma of k cubed as k goes from 1 to n is equal to n squared times n plus 1 whole squared divide that by 4. 5 times sigma k squared, so that's 5 times this, 5n times n plus 1 times 2n plus 1 divided by 6, and you have to add 4 times that, so that would be 4 divided by 2 is equal to 2, so that's plus 2 times n plus 2 times n plus 1. Times n plus 1. So now we need to basically find out what this whole thing, when we add it together, what that becomes. So over here we have n squared times n squared plus 2 times n plus 1, which is equal to basically n raised to the power 4 plus 2 times n cubed plus n squared. So that's the first part. We have n raised to the power 4 plus 2 times n cubed plus n squared divided by 4. Over here you have 5n squared plus 5n times 2n plus 1. So that's 5 times 2 is equal to 10n cubed plus 5 times n squared plus 10 times n squared. 10 times n squared plus 5 times n, which is equal to 10 times n cubed plus 15 times n squared plus 5 times n. So that becomes basically 10 times n cubed plus 15 times n squared plus 5 times n. Divide that by 6. And then over here you have 2n squared plus 2n. And then if I add all of these together, I will get, I'll take a 12 LCM, so 3 times n raised to the power 4 plus 6 times n raised to the power 3 plus 3 times n squared. 2 times this would be 20 times n cubed plus 30 times n squared plus 10 times n. And 12 times 2 is equal to 24. Is equal to 24, so that's 24 times n squared plus 24 times n. So then you have basically 3 times n raised to the power 4, so 6 times n cubed, 20 times n cubed would be 26 times n cubed. 3n squared, 30n squared, 24n squared, that's 54. 57 n squared. 10 plus 24 is 34. 34 times n divided by 12. Well, you cannot simplify this because 57 is the same thing as, you can divide this by 3, but this can only be divided by 2 and 17. So let me see if I can have any mistakes. Which means that I suppose we can write this as probably take an n out here. We can take an n out here, so we write this as 3 times n raised to the power 4 plus 26 times n raised to the power 2 plus 57 times n plus 34. And then you can, I think 17 times 2 is equal to 14, 1, 34, so that's 2 times 17. And that's supposed to be raised to the third power. Now the zeros of this polynomial would be probably 2 or 17 or 3 or 6, for example, or something else really. So there is no way to know. And in order to find out one of the zeros of this polynomial, I'm just going to give you a calculator. I'm going to call this 3 times n cubed plus n cubed plus 26 times n squared plus 57 times n plus 34. Call it f of n. There is 1 and negative 2 and some other number, so you can, negative 1 and negative 2 are zeros of this polynomial, so you can write it as basically negative 1 and negative 2 are zeros, so you can basically divide this by basically x minus a, and x minus a would be x minus negative 1, which is x plus 1. So if you divide by x plus 1, you will get 3 times n raised to the power 3 plus 26 times, that's actually n, 26 times n squared plus 57 times n plus 34, divide by n plus 1, you will get 3 times n squared, which gives you 3 times n cubed plus 3 times n squared, negative, negative, and then you will have these two cancelled out. 26 minus 3 is equal to 23 n squared plus 50 plus 57 n. Now 23 n squared divided by n is equal to plus 23 times n. 23 times n squared plus 23 times n. Negative, negative, you can cancel these two out. 57 minus 23 is equal to 4, 34. That's 34 times n. That's 34 times n plus 34. And then if you multiply by, add the 34 here, you'll get 34 times n plus 34, and you'll get a 0. Which means that you can write 3 times n cubed plus 26 times n squared plus 57 times n plus 34 is equal to 3 times n squared plus 23 times n plus 34 times n plus 1. And so what that means is that So this is divided by 12, so I can write this as n times n plus 1 times 3 times n squared plus 23 times n plus 34 divided by 12. And that is the correct answer there. Okay. So that was question number 8. Okay, so question number 9. Question number 9 is also an interesting question. Basically, you have a series, and the series is a of n here is equal to n squared plus 2 raised to the power n. So you see that over here you have 2 raised to the power n. And 2 raised to the power, and so basically then s of n would be equal to sigma of a of k as k goes from 1 to n, of course, which is the same thing as sigma of k squared plus 2 raised to the power k as k goes from 1 to n. And that is the same thing as basically sigma of k squared as k goes from 1 to n plus sigma of 2 raised to the power k as k goes from 1 to n. And, well, we have a formula for this. You know that sigma of k squared as k goes from 1 to n, that is equal to basically n times n plus 1 times 2n plus 1 divided by 6. Now this thing over here, we don't have a formula for that, but if you write this as sigma of 2 raised to the power k as k goes from 1 to n, that would be the same thing as basically 2 raised to the power 1 plus 2 raised to the power 2 plus 2 raised to the power 3 plus all the way up to 2 raised to the power n. And as you can see, this is a geometric series, meaning that your a is equal to 2. Your a is equal to 2, and your basically your common ratio r is equal to 2, meaning that every time 2 is multiplied by each term to get to the next term. And you know that in a geometric series, s of n is equal to a times r raised to the power n minus 1 over r minus 1, right? Which means that here your s of n would be equal to 2 times r, which is equal to 2 raised to the power n minus 1 over 2 minus 1, which is the same thing as 2 times 2 raised to the power n minus 1. So I can add these two together and write them as basically n times n plus 1 times 2n plus 1 divided by 6 plus 2 times 2 raised to the power n minus 1. And that is basically the sum there. You would get an expression. If you expand this and add them together, you would get some sort of expression which would not be very helpful. So I'm not going to do that here. I've already done that once. It's not going to be simplified much. Question number 10, we have basically a of n is equal to, again, 2n minus 1 raised to the power 2, which is the same thing as 2n whole raised to the power 2 minus 2 times 2 raised to the 2n times 1 plus 1 raised to the power 2, which is equal to 4n squared minus 4 times n plus 1. That is your a of n. That is your A of n, which means that you will get basically your S of n would be sigma of A of k as k goes from 1 to n, which is the same thing as sigma of 4 times k squared minus 4 times k plus 1 as k goes from 1 to n, and that is equal to basically sigma of or 4 times sigma of k squared as k goes from 1 to n minus 4 times sigma of k as k goes from 1 to n plus sigma of 1 as k goes from 1 to n. So again, you know that basically sigma of k squared as k goes from 1 to n is equal to basically n times n plus 1 times 2n plus 1 divided by 6, and you have a 4 multiplied up front, so that would be 2/3, and then you have negative 4 times k, so sigma of k as k goes from 1 to n, which is equal to n times n plus 1 divided by 2, multiply a 4 over here, you will get 4 divided by 2 is equal to 2, and sigma of 1 as k goes from 1 to n is equal to n, right? N times 1 is equal to n. So you have so you can basically take an n out here, so you can write this as n times 2 times n plus 1 times 2n plus 1 divided by 3 minus 2 times n plus 1 plus 1, and so now you have to basically add all of these together. So you have n plus 1 times 2n plus 1, so you have basically 2 times n squared plus 2 times n squared plus n plus 2 times n plus 1, and multiply 2 by that divided by 3, you will have basically 4 times n squared plus 2 times n plus 4 times n plus 2, and that is 4 times n squared plus 6 times n plus 2, and so you will have over here you will have n times 4n squared plus 6 times n plus 2 divided by 3, so minus 2n minus 2 plus 1, okay? And then you can write this as n times okay, so let me see. Okay, so you can write this as 4 times n squared plus 6n plus 2 divided by 3, negative 2n, negative 1. And then you can write this as basically n times basically take a 3 as LCM, 4 times n squared plus 6 times n plus 2. And negative 6 times n negative 3, right? And so that would be equal to would be equal to n times 4n squared. These two will be cancelled out, negative 1 divided by 3 divided by 3 and I think you can write this as well. What you can do is that you can write this as basically n times 2n whole squared, which is 4n squared minus 1 squared. Now this is a squared minus b squared, which is equal to a minus b times a plus b. So that based on this, 2n whole squared minus 1 squared would be equal to 2n minus 1 times 2n plus 1 and divide by 3. So you will have basically, you will have n times 2n minus 1 times 2n plus 1 divided by 3. And therefore S of n in that case would be n times 2n minus 1 times 2n plus 1 divided by 3. That's basically what we were looking for. Okay, so that is basically these were all the questions that we had. We have a couple of miscellaneous examples here. We will go through the miscellaneous examples, and we have some miscellaneous exercises as well. So I'll see you in the next video. Thank you.